I am Maria Perbellini, the Dean of the School of Architecture and Design, New York Tech. Today's book discussion is hosted within the Collateral event Students as Researchers, Creative Practice and University Education that I curated together with New York Tech professors Marcella del Signore, Athina Papadopoulou, and Sandra Manninger, and is located at the Armenian Culture Studies and Documentation Center in Dorsoduro in Venice, in Italy. Our event let me give you a very brief background. Our event is one out of 9 collateral events admitted by Lesley Lokko, curator of the 18th International Architecture Exhibition titled The Laboratory of the Future and organized by La Biennale di Venezia. And we are thrilled about the presence and contribution of 20 universities with 25 student projects from all over the world, translated and composed into a collective installation, University Dialogues, which embodies the candid reflections developed by the students in a broad variety of investigations and with the support of faculty tutors. Our proposal for the collateral event is supported by the commitment to provide a resonating platform for ongoing and actionable efforts toward the imagination of future ways of being in the world. And we want to explore a range of possibilities to build an active role within experiential learning, addressing investigations on urban adaptation and climate change, the well-being and safety of inclusive communities, but also, and this book presentation is fitting extremely well in what we are very sensitive about, which is the critical role of innovation and emerging technologies. We can be preventive, and we can also proactively and creatively anticipate transformative processes and continuously evolving learning experiences that prepare students to engage with leading design practices and research trajectories. So, in addition to the exhibition that is at the center, at the Armenian Culture Center, we also include, until the end of the Biennale in November, events and multimedia exhibitions, workshops, symposia, publications, presentations, dialogue, conversations, book launches, and more. We have a very rich program. And today, as part of all these activities, we are very pleased to welcome to the conversation on artificial intelligence, and particularly the presentation of Pablo Lorenzo-Eiroa's book that was just published by Routledge, and it has already attracted great interest. And the title is Digital Signifiers in an Architecture of Information, from Big Data and Simulation to Artificial Intelligence. I would like just quickly quote the book content. The book proposes a new critical relationship between computation and architecture, developing a history and theory of representation in architecture to understand and unleash potential means to open up creativity in the field. And I would like now to extend a warm welcome to Professor Pablo Lorenzo-Eiroa, to Professor Marcella del Signore. She will follow with an introduction, and to the guest respondent and moderator, Professor Alexis Meyer. And please, Marcella, I would like to invite you to continue with the program. Thank you so much, everyone, for attending our event today.
Thank you, Dean Perbellini, for the opening remarks. It's a pleasure to be here and be in Venice virtually and really be part of this important event as part of our continuous event during the Biennale. Hello, everyone. So again, good morning and good afternoon. I'm Marcella del Signore, an associate professor and director of the MS in Urban Design at New York Institute of Technology, School of Architecture and Design. And also, as Dean Perbellini mentioned, one of the 3 deputy curators, along with Athina Papadopoulou and Sandra Manninger, of the Students as Researcher Venice Biennale Collateral event. So I'm very excited to introduce the event now in more detail, but particularly to introduce the speakers for this book launch. So the book discussion today is titled Artificial Intelligence, Digital Signifiers in an Architecture of Information, from Big Data and Simulation to Artificial Intelligence. The book is written by Pablo Lorenzo-Eiroa, PhD, Director of the AI Research Lab and Associate Professor at New York Tech School of Architecture and Design. And the book is published by Routledge, London, 2023. So in particular, the book discusses research anticipating the role of big data and simulation necessary to activate what is being called AI. Big data and statistical prediction are essential to activate parallel processing, emergent programming, as well as generative AI, artificial intelligence. Proposing an architecture of information compatible within the 21st century, the book takes sections through history, redefining architecture theory based on big data, forensic surveys, and expanded machine vision simulations, exploring non-intuitive data and modeling relationships, deconstructing history to expand new possible futures. In particular, the book traces critical relationships between technology and culture, displacing specific media and mediums to be able to convey specific messages. For instance, data and AI bias as lack of cultural criticism, or design as a cultural confirmation bias. Also, the book expands relationship between computation and architecture, including the definition of new fields of knowledge, deconstructing neocolonialism implicit in a digital feudalism, from measurement and representation system, data bias, and anticipatory computation, to expanding authorship to critical relationship between data science and computer science. After Nietzsche's Every Word is a Prejudice and Barth's Language as an author, natural language processing, prompt engineering, grammar, activate computer programming, projecting, conventional semantics, a context to which we define and expand relationship between a computational linguistic semiotics, a computational visual semiotics, and an informational semiotics. The crisis of representation of nature is redefined by thermodynamics, expanding architecture and urbanism as emergent space environments. And we propose to deconstruct the conventional artificial origination of science in computation towards a metal, ahistorical, multidimensional architecture of information. So with that, I have the pleasure to introduce the 2 speakers today. So our speakers are the author of the book, Pablo Lorenzo-Eiroa, PhD, Director of AI Research Lab, again, Associate Professor at the School of Architecture and Design at New York Tech. Dr. Pablo Lorenzo-Eiroa is an Associate Professor, Director of the AI Lab, and also the first founding Director of the MS in Architecture and Computational Technologies program at SOAD at New York Tech. He's an international architect and scholar in the field of architecture, urbanism, ecology, and computation. His work innovates in an information-based representation and construction system through materials, robotics, and digital fabrication. He received his doctor in architecture degree from UIC Barcelona and his architecture degree from University of Buenos Aires, where he completed studies for his second master's degree and a postgraduate seminar at the Superior School of Fine Arts de la Corcova. He then won the Fulbright and the National Endowments for the Arts scholarship to complete his first MR2 at Princeton University. Professionally, Lorenzo-Eiroa is design principal of experimental practice e-architects based in New York and Buenos Aires, based on an emerging architecture and urbanism of information. E-architects develop software, information mapping and visualization, implementing big data, including machines to draw and machines to build, understanding them as proto-architectural. His built work includes park building and installation in Buenos Aires, New York, and Europe. I have now the pleasure to introduce as a responder and moderator. I would like to welcome Alexis Meyer, PhD, architect. So Alexis is an architect, is an associate professor in theory and practice of architecture and urbanism. He's at the ASBU master degree, AMUP lab at the National Institute of Applied Science in Strasbourg. Alexis Meyer is an architect and doctor in urban and architectural conception theory and project. He started his career in with the architect Peter Eisenman in New York and with Renzo Piano in Paris. He's a university lecturer at the INSA in Strasbourg and collaborates with NSAS since 2009. His research deals with the understanding of mechanics at work in the project conception. He's also interested in the modeling of new organizational logics, flow of forms, information, and material that creates new links between the person, the space, and the environment. He develops managing strategies to redefine the traditional urban systems. So please join me in welcoming our speakers and moderators. And I will now have the pleasure to pass the floor to Pablo for the book presentation. Thanks everyone for being here.
Thank you. Thank you, Marcella. Thank you, Dean Maria Perbellini, and thank you to the co-curators of this event, the amazing participation of New York Institute of Technology at the Venice Biennale. I'm honored to be here, and I thank you for all the organization and the possibilities. The co-curators, of course, Marcella again, always everywhere. Thank you so much for all the work that you do for NYIT. Sandra Manninger and Athina Papadopoulou, who is also the chair of the Lectures and Event Committee. So thank you, everybody, for giving me the opportunity to present to you the ideas of the book. This is the first presentation that I do on the book after it's published. I just received the copy of the book 2 weeks ago. It looks actually very well. It's very well printed, so I'm very happy. It was a lot of work through several years. So here we have the copy. Alexis Meyer's critique is actually in the back, a very precise critique, so we're going to talk about it. I just wanted to say that in this first presentation, I'm going to focus on the relationship between computation and language, especially not only because it's an aspect of my research that I've been working through the last 20 years, but also because of the relevance of natural language processing. So this first presentation is going to be specifically about language. I'm going to try not to show too many images to save for a presentation that I'm doing in 2 weeks or 3 weeks from now that is going to focus on practice. So this first introduction is going to be more theoretical, and the following one is going to be actually dialectical. It's going to focus on urban systems and mobility that we're actually exploring in the city of New York and that we want to apply in Europe. So giving a little background of myself, in 2010, we did with Aaron Sprecher and Shai Hayahu, Acadia 2010, in which we explored, at least I presented the problem of the bias in computation, which at the time was not, people were not so familiar with it, and the problem of authorship in relationship to background coding. In 2013, we published with Aaron Sprecher Architecture Information, in which we invited guest editors and writers to discuss what is the possibility for an architecture of information. And we divided in different chapters and different spectrum, all the way from data to issues of perception, such as affect. And in this book, I discuss more formally what was a digital signifier. And I discussed the theory of what I meant by authorship in trying to critique and expand Negroponte's idea of mechanic authorship. In the last years, I was, by the way, in the architecture information book, I anticipated the necessity to actually work with parallel processing and blockchain as a bifurcating network structure. And the interesting thing was that since 2013 until now, artificial intelligence actually started having certain degree of functionality thanks to big data. So since 2010, I've been working quite hard on big data and what big data means for architecture on many aspects. On the one hand, with API, and on the other hand, with increasing signal levels, such as laser 3D scanning and photogrammetry, trying to develop our own data sets and our own databases and our own data repositories, anticipating what was coming. Since I was familiar with what Google was doing and Facebook was doing, I thought that we had to resist that problem and create our own data sets. This is a little meant to be a little bit of my evolution in my relationship with computation. I started scripting in a school, a very special school in the 1980s. When the first PC came up, I was able to start with basic programming. In high school, we saw a little bit of Pascal and C. And then in the 1989s, I started getting familiar with artificial neural networks, thanks to my mother. My mother worked with researchers of Palo Alto Institute who were studying with Bateson on the problem of adversarial feedback, which is one of the things that we discuss in the book. Then through the years, I'm not going to go through everything that is on the slide, but through the years, I became more and more interested on the problem of emergent programming and simulation. If you know my work, you know that I've been working on simulation for several years with computational fluid dynamics on the one hand as a form of big data simulation, but also other types of simulations such as expanded virtual reality and so on. The interesting thing to me happened around 2017 with the GANs, generative adversarial networks. But today I'm going to focus on linguistics because I think that what's going on with the current concern about bias is that I had a statement that thinks that the current AI bias is because the neoliberal agenda is displacing humanities from education. I think that that's the first problem that we have. AI it lacks of cultural criticism because of the way the neoliberal model has been presenting technology as a impulsing force for our society, and the lack of criticism of how that technology is applied, or the cultural baggage that technology is embedded with. I think that technology has bias because technology is done by developers, and the developers have ideas about representation of reality, and we're going to discuss specifically how they are conveyed. The book has 5 sections: representation, semiotics, dimensionality, actualization, and simulation. These are big titles. Within them, there are different discussions and different levels of the problematization of what these big titles are. I'm not going to go through all of them because I expect that you buy the book and that you go through the book, but the idea is to give you a picture of the complexity of the book. This book took me a lot of time to develop. Actually, it's part of my PhD research at WIC with Alberto Esteves and Alexei Meyer next to me, and also research done at the New York Institute of Technology and at the Cooper Union. The table of contents goes through problems of history, trying to develop an alternative history of architecture by not only developing our own surveys, but actually deconstructing how theory was based on a certain particular lenses of history. So in that sense, I follow Tafuri's sections of history, and I try to disarticulate what is known about certain buildings, and we develop alternative histories about them. And then at the end, the book deals with thermodynamics and computational fluid dynamics, specifically in terms of emergent space environments. But within those two things, and then this multidimensionality in between, I'm going to focus, as I said today, in linguistics and visual semiotics. The paragraph that Marcella read today is one of the posts that I did in Facebook. So I thank Marcella for the clarity of introducing the subjects of the book in relationship to what I've been trying to articulate, which is how do we deal with the fact that computation deals with language and mathematics? It's not mathematics alone. Most of the people think that computation is only mathematical, and it's not. It's alphanumeric. It's about the relationship between language and mathematics, because there are statements such that need to be proven valid or not, thanks to the discrete logic of algorithms. And we're going to discuss in certain diagrams how that works. In future lectures, I'm going to discuss more particularly the opposite of computational linguistic semiotics, which is what I'm going to focus today, which is computational visual semiotics, right? I pair the relationship between linguistics and the visual. I try to make relationships between the linguistic and the visual, and I try to argue what are the advantages and disadvantages of linguistics in relationship to the visual, and the disadvantages of the visual in relationship to itself and other systems and other computational systems. The first notion that I want to convey is the fact that the metaphysic project of computation has been there for a long time. Aristotle had envisioned a system of syllogisms, which he called organon, in which he describes ways to rule out ambiguity. The ruling out of ambiguity is the basic of an algorithm, right? An algorithm is actually a way to, in binary terms, to actually rule out ambiguity. Aristotle thought about that. How can we rule out ambiguity in relationship to what he calls the laws of thoughts? And he discusses analytics, logical and sophistical refutations in relationship to logical statements. This is a long time ago, right? We're talking about 350 before the Christian era. The other, and I develop a little bit of a genealogy of the interests that are related to my theory of computation. This is a very particular and subjective section. That's why I argue Tafuri's section of history, right? I develop my own section in order to create an argument, and there are other avenues that one can follow. So this doesn't mean that this is the truth, but this is helping me build up an argument. The second problem that I'm interested in is the Characteristicas Universalis of 1666 of Leibniz. He called it in many different ways, Dissertatio de Arte Combinatoria, or Diagram of Reasoning, in which he tried to articulate mathematics, science, and metaphysics. To me, this is an important problem. He owned the I Chings, that's an important fact in history, and he added numerical values to the I Ching and alphanumeric. So he was concerned about the problem of language and the problem of mathematics, and how to combine science in relationship to language and mathematics. So to me, he had embedded the metaphysics of computation already. And he called it, of course, for a universal formal language. If you are familiar with language and linguistics in general, universal grammar is the subject matter of several linguistic researchers. And why it's important? Because languages are not perfect, they're imperfect, and we need to aim to have a universal formal language that is able to contain all languages, so that we are able to expand certain languages. I argue, for instance, that instead of English, we should be using Sanskrit. Sanskrit, to me, is a higher level grammatical language of South Asia, 700 before Christian era, and then with edits, in which the language itself has multiple ways of referring to reality. It has a more expanded way of conceiving reality, such as multiple plurals, multiple genders, and many of the things that we are trying to deconstruct today that are already embedded into Sanskrit. The other interesting problem of closer to our era is George Boole and Boolean algebra, or Boolean logic of 1834, which is particularly an investigation of the laws of thoughts by Aristotle, but taken into a binary yes-no logic. And this is where the beginnings of the logic of computation starts emerging. Of course, nobody paid attention to George Boole until Shannon actually included a Boolean logic in his thesis of 1937. But before Shannon, the universal Turing machine by Alan Turing devised a way of having a tape in relationship to mechanisms that would calculate individual equations, and then in terms of a series, will throw one calculation into a different calculation into a different calculation. And I'm going to show you some machines that were already proposing that. The important thing about Claude Shannon's theory is that he applies the Boolean logic to a binary logic of circuits. So for the first time, we have a yes-no argumentation trying to rule out ambiguity in relationship to an electrical circuit. He based that on the telephone switch, and he aimed to develop a mathematical universal communication system. The mathematical theory of communication came out as a thesis in 1937, as I said before, but also Shannon was a cryptographer, and he envisioned the problem of the economic advantage of translating a message into encrypted data and then decoding that data after it's being transmitted in terms of a digital communication system, which we're going to actually discuss and also criticize, because to me, we have to do something there that I think is missing. Shannon developed the principles of what is called today the information theory. This series of analog computer machines and digital computer machines were revolutionary, and in parallel to what I presented in the previous slide, which is related to, if you want, more metaphysics, right? Ideas about how to address reality. And here, some of the same people were able to actually develop physical mechanisms that they prove the idea. And this is what is so important about them, and why I developed another section, which is analog computation and digital computation, but the machines that actually prove the concept. In the year 200 before the Christian era, we already have the Antikythera machine that was discovered. Was discovered a while ago, but recently there was a 3D scanning and a simulation and reconstruction that proved actually its complexity more than what was previously assumed. The Pascaline, which is Pascal calculator of 1649, the Pascaline to me is quite revolutionary because it looks very similar to Alan Turing's machine. That's why I put it here. The Calculus Ratiocinator by Leibniz, which already proposes a universal logical calculator. It's actually a computational system to devise statements, not only to make calculations, but actually its idea was actually to create a logical system and to compute a logical system. Then in 1725, we had the Bouchon punch card, which the Jacquard-Loomis machine came up in 1804, which to me is also revolutionary because it devises a punch card, which is a digital system, is binary, but it's analog, right? It's binary system, not digital, sorry, it's a binary analog, but the binary system gives an indirect order, which is encoded to a Loomis machine that creates a textile weaving. Already anticipating what Shannon was saying, the fact that in information theory, to me, the revolution of the Jacquard-Loomis is that it's anticipating Shannon's information theory, that it's more convenient to translate a message into a different type of form, in this case, a binary punch card, in order to produce a sequence of operations. The Alan Turing machine, which we are all familiar because of the movie, I'm not going to go through it, but particularly the halting problem and Gödel undecidability we discussed in the book. And Claude Shannon did one of the first automata, working automata, which was able to resolve a maze, a mouse that was able to resolve a maze through electrical impulse by itself, right, in the 1950s. Now, the important thing here relative to languages is that, and I'm going to say something that is controversial because a lot of people would not agree with me. On the one hand, we have computational linguistic semiotics, which I am trying to develop as a not only as a theory in relationship to architecture, but a little bit of an independent field of study, which already exists, but I am trying to articulate in relationship to architecture. And on the other hand, on the other spectrum, computational visual semiotics. Between these two areas, I'm trying to develop two specific areas of knowledge that I think they had not been developed enough, and I'm trying to expand them into new disciplines. On the one hand, linguistic semiotics deals with programming languages, and computational visual semiotics deals with signs that are able to become visual signs, right? Such as a pixel, particles, or points, which are the three basic digital signs that I developed in the book. But also, I based this theory, of course, on the revolution of shape grammar, which actually is computation through form. And we're not going to focus on that today, but I leave that to another lecture. But the controversial statement here is that mathematics, to me, is part of semiotics, is a type of language. I don't think that aliens coming from another world are going to discuss mathematics in our terms. I discuss in the book that mathematics is a decimal system because of our 10 fingers. So it's anthropomorphic and anthropocentric, meaning that it's not universal, meaning that aliens that may have different rows of fingers or different ways to count will have a different type of mathematics based on a different measuring system. And I think that here is where all the mess starts, because what I'm trying to deconstruct is that computational linguistics have problems, mathematics have problems, and computational visual semiotics have problems. And how do we deal with them in architecture? The first problem is that we cannot think outside of language. This is a statement that I did not invent, but is something that many linguists have been thinking about. And there is another problem which Chomsky refers to, which is that language produces a certain type of synapses connections in our brains. And there are CT scans of brain activity that actually confirm this now. Meaning that if you speak language, English, all your life, or if you speak Arabic all your life, your actual brain neural connection synapses is different. And here is where Chomsky's theory becomes revolutionary, because Chomsky argues that the grammar of language is a way, a structure that is more important than meaning, and that literally our brain synapses is structured after grammar, meaning that the grammar of language actually has a physical effect on our brains and allows us to understand reality in a certain spectrum. So for linguistics, for people that study language, language itself is what allows you to think about, like what's possible thinkable. And if you don't deconstruct language, here's where the problem starts, because you assume that you are understanding reality, but in reality, you're missing a spectrum of reality. So the discussion today tries to articulate what are we missing with natural language processing? What are the problems of ChatGPT? And what are the problems of creating images with ChatGPT or based on large language models? For Nietzsche, we have different philosophers that actually problematize language, and I have a genealogy in the book discussing them. Nietzsche says every word is a prejudice, meaning that in the word itself we are already classifying. Wittgenstein, the famous Tractus Logico-Philosophicus, the limits of my language mean the limits of my world. And Barthes says that language is the real author, that in literature, the limit of language is, the limit of literature is language itself. This to me causes a problem with computational linguistic semiotics, because computational languages are mostly based on English. There's a lot of people that actually realize that that's a problem. And C, Python, any language, right, based on grammar, in English grammar, already has embedded a certain structure of thinking. Of course, we have different types of language that we're going to discuss later, from higher to low, and we're going to see what are the problems of that. The Renaissance, at least for the visual arts and architecture, proposed the system of representation as an author. And I mentioned Brunelleschi, which is problematic because I try to deconstruct how present still today perspective is. It's not that I am doing a claim for perspective, but all the things that I include in the book are trying to criticize what they mean. And I think that one of the problems of artificial intelligence today related to machine vision is that we have the bias of perspective. And I think perspective is actually there all the time in a very conventional way, actually. Negroponte claims that the computational system is the author, but then what happens with architects, what happens with designers? And that's what the book discusses. How do we elevate our level of authorship relative to creativity, and how much the system weights in terms of anticipating a certain degree of authorship. Chomsky, I describe a little bit of what this means. I'm not going to go in detail because it's more developed in the book, but Chomsky studies the problem of grammar, and he disguised the fact that you can have a grammatically correct sentence, which actually doesn't mean anything. And he argues that grammar is autonomous and independent from meaning, flipping the equation. And that's when generative grammar comes in. And I think that that's where semantics is totally wrong. I think that today, I saw an article a couple of weeks ago about the weight of semantics in artificial intelligence as an advantage. And that's, I think that's the problem that we have today, that semantics is totally biased because of not understanding this problem that Chomsky points out, that the grammar is in itself generative, meaning that semantics becomes irrelevant. So if we are going after semantics, we actually need to either deconstruct the bias of the culture, or we need to deconstruct the structure of the grammar. Marvin Minsky, we discussed in the book the problem of reinforcement learning based on the theory of feedback, and also the problem of language in relationship to syllogisms and meaning related to machine vision. And other principles such as the double feedback problem that based on figure out, and there's other cybernetics of cybernetics. We discussed through the book the problem of grammar prediction, which is actually a problem of the 1970s, and is what ChatGPT is based on, right? It's actually ChatGPT anticipates by a prediction model how much percentage of possibilities after one word is entered, the next word is predicted, and the more words you put in, the more prediction accuracy builds up. So ChatGPT is basically a statistical problem that was devised very early on, but now it became functional because of the amount of data that we are able to access, which is also a problem because the data that these systems are accessing breaks a lot of copyrights and user privacy laws. So what is the digital signifier? What is a signifier? I do a genealogy of the relation between the sign and the signifier in relationship, of course, to the Saussure. The Saussure says that the sign is the signifier over the signified. The signifier is the word, and the signified is the thing that the word is referring to. But after an evolution of that relationship, what Jacques Derrida figures out the clue in relationship to what Chomsky was actually articulating, which is that the signifier itself can actually convey meaning. And this is where the problem starts, the struggle, right? The fact that when we name something, we're actually creating an object independent from what we are being named. And if we refer to semantics in ChatGPT, the problem is that the semantics is actually referring to something which is itself an artificial construction, independent from that something that is being constructed. Moreover, the grammar through which that semantic is interpreted, it's itself generative. So we have two levels of dissociation in ChatGPT. One is meaning independent from the structure, and the other one is meaning in relationship to semantics. This is a diagram that I developed in 2008 and 2010, in which I was claiming that architects were working more on the left side of the diagram, and we needed to work with non-linear algorithms, parallel processing, and bifurcating systems, which is blockchain basically and artificial neural networks. At the time, artificial neural networks 2008 was a bad word, so I didn't use the word because of the problems associated with it. But now, with the amount of data that we have, artificial neural network prove that they're actually working. And in architecture, we have different ways of drawing and different ways of representing. I discuss in the book the different signs and how architects draw in relationship to the systems that are provided to them, usually developed by a computer software developer, which is another separation that I problematize during the book. But mainly, one of the interesting things to me is the flip in the functionality of artificial intelligence, which is thanks to big data, that before we had simple algorithms, complex algorithms with simple data, and now that equation flipped. We have a lot of data and simpler algorithms. And that the weight of statistics in relationship to algorithms start being higher, meaning that the statistical data is actually challenging the model, the AI model. So we have data science and computer science a little bit competing against each other. So we have the model that anticipates the solution to a problem, because you cannot do a software. In order to do a software, you need to anticipate what type of problems you're going to resolve. And data science is totally the opposite. That tries not to anticipate anything, and through the data tries to depict what are the patterns and devise what type of problem is emerging. Now, of course, we have the problem of curve fitting and other issues that we discuss in the book that are also biased, that are also model-based, but the idea of scientific validation of big data is that the data will compensate the intuition. And in the book, we jump back and forth with artificial neural networks and convolutional neural networks. Artificial neural networks are more related to language, although some linguistic models use the CNN, and the other way around, right? Convolutional neural networks are more related to the image processing through convolution and pixel decimation, and they have a different structure. In the book, we go through these problems. We go through what is an architecture of information, what are the type of linguistic signs, and what are the types of visual signs, and what are the formal problems in relationship to that, in order to arrive to what I call the e-architect, which is how architects can develop new parameters, systems of reference and measurement, to be able to expand authorship and actually to create a certain type of emancipation from what I call what Varoufakis called the digital feudalism that we live in today, in which ChatGPT is a black box system that is gigantic, and an individual has no chance to compete against it. So these are the digital signs, some of them, of course. Every software is loaded with a digital sign and anticipates the type of problem through a matrix of what it can resolve. And I think in computational visual semiotics, this is a problem, that the computer space is already biased, as I claim in 2010, and how architects deal with that background is, to me, the most important thing. It's not so important to me the content, but actually how you struggle with the loaded bias ideological background. And these are the sequence of problems that I discussed: authorship, how to come up with an ahistoric process, what is a computation and architecture, which are not the same. Most of the time, we see architects doing architecture through computation, but in reality, it's more on the side of the computer software programmer than architecture. And how we can disguise and resolve an architecture of information. I think that we need to displace the signifier, otherwise bias come in. So here I'm going to talk a little bit more about ChatGPT, natural language processing, and what are the problems of pixel to pixel image processing that we're seeing every day in constant feed in social media and so on. One of the three areas, right? Computational linguistic semiotics, mathematical semiotics, and computational visual semiotics deal with the problem in different ways. And the idea here is to go back and forth to try to disclose how we can move forward. The problem to me of computation relative to people are scared of AI taking over, and I think that we are right to be concerned about it. I think that we are here. These are different phases: binary, computational languages, artificial neural networks, emergent computation, which is what I think we are doing today, and what von Neumann anticipated, which is what will happen if this becomes exponential. In other words, today, we are working with artificial neural networks having self-editing algorithms, which they are able to optimize themselves, right? Every cycle in a non-supervised machine learning, the cycle becomes more optimized. And the optimization of that cycle makes the computation more effective. In some cases, it's able to recognize a feature in the data and is able to create its own program. And this is when the scary and interesting part comes in, that this is called what I call and other people call emergent programming. And that's what I'm aiming for. I think that we can do with natural language processing emergent programming, but the problem is how do we achieve that in relationship to the different language levels. So we have low-level language, programming language, which is assembly and the machine language. We have low code, which is visual algorithms such as Grasshopper is considered a low code. Then we have natural language processing based on stochastic grammar, which is what we're all working with today. Then we have prompt engineering, which is grammar-based. And then we have the high-level programming languages, which is what software programmers do. We have to be careful because on the one hand, natural language processing, yes, you can activate a high-level language programming level, but it's not the same. You cannot replace it. Of course, it's becoming better than programmers, but you need to know why or when or how to edit. Because the thing that it gives you, ChatGPT, the thing that it gives you, even it gives you the Python result, is an optimization, and it doesn't know the meaning, right? And it doesn't really have knowledge embedded. It has knowledge in a certain minimal level, but it's not the understanding of the knowledge. And here we are. This is what I'm dealing with now. I'm trying to create a morphogenesis out of a computational system that can actually literally evolve in order to achieve emergent programming. And this is a step before the singularity, right? This is where everybody's concerned about. Von Neumann, by the way, is the person you are familiar with. He devised the Manhattan Project. He was one of the responsible for the atomic bomb. He was interested in the self-implosion, in the exponential logic of the self-implosion. And actually, artificial intelligence is being compared to the atomic bomb because of this idea of implosion. It's actually based on an idea of emergent implosion. So the singularity of AI can be given by an idea of self-simulation becoming exponential and exploding or imploding, and the fact that data is everywhere, and that because of the Internet of Things, the entire world is wired, and the more wired and more data gathering you have, you're actually increasing the dimensions, like our brain functions, of data circulation until a point in which the information flow can become actually self-conscious. And that's the AI emergence problem. I claim that, we went through all the systems. We started working with ChatGPT early on, 2020, 2021, and 2022. So we follow the evolution. We first started working with prediction language in relationship to cellular automation, creating floor plans out of a text, out of a predictive text. But in relationship to images, this was happening, right? The fact that in 2017, 2021, NVIDIA started developing, you probably know, because of the GPU, artificial neural network become more efficient. because of the processing chip that NVIDIA developed for video cards. And in 2017, the problem of the GANs, right, generative adversarial networks based on semantic segmentation, became what was called style transfer, right? That you could actually identify features in an image and then transfer that style into a different image. Now, there are different processes of that. One is convolution, which is more sophisticated, but the other one is based on image tagging, ImageNet, which has been highly problematic because of the bias, right? ImageNet is based on linguistic bias, and this is what I'm claiming that is a problem, because we're saying black, white, and I am not white, I'm not black, nobody's black and white, right? We are projecting a signifier into people's color of skin and then creating a problem with that. That's what's the bias in the data, because the images are being tagged following a linguistic bias and a grammatical bias. So when you do semantic segmentation, the semantic to me is bias. Sky, column, ceiling, floor, right? They're all biased because they are based on conventions. So how do we do architects that we're actually trying to deconstruct conventions? And I think that ChatGPT is working, such as through Midjourney and so on, because it's interpolating. But the problem of the image tagging bias is there. We develop a way to surpass that problem through emergent programming, but still is there. So one of the issues of pixel-to-pixel diffusion models was a little bit anticipated by certain software programmers that were working with art. And I argue that the stereograms was actually something out there, is not computationally doing the same thing, but there were textures that started to look like images. And when you work with diffusion models, right, the noise and denoise function, right, is based on actually von Neumann's. Von Neumann is a person that comes through the entire book in our case, because von Neumann devised the idea that diffusion models are based on, that you can actually create order out of disorder. So he based a theory on resolving deterministic models out of non-determination. If you are familiar with thermodynamics, thermodynamics is about simulation and non-determination. And what von Neumann did was actually to devise ways to resolve through thermodynamics certain specific problems. The diffusion models are based on thermodynamics. There is a noise that through thermodynamics deconstruct the images into noise, literal pixel noise, and then an adversarial convolutional process tries to reconstruct everything back again. The relationship between diffusion models and image making is very interesting. We started this back in 2022 in July when Midjourney started being available for us, you know, obviously the interpolation is very interesting and it creates a lot of complexity. But how do we, you know, the more you train the models through convolution, right? First, we initiate a linguistic prompt engineering that becomes a higher language level. We try to activate a higher language level because I know some grammatical issues in computation that can trigger certain problems and then create a high level programming language and activate an actual program, an emergent program. But we discovered that there was a limitation. The limitation in the image making was exactly the semantics, that the image gives you what linguistically you're imagining. But through convolution, you can actually train the model to actually look for features and actually predict a different deviation from the linguistics. And that's what we were interested in. We also work with 2D to 3D. I never published them. I know that a lot of people were doing this. We did actually very early on, 2001, 2021, and 2022, in which we took a 2D image and we combined different techniques that were developed in 2017 in Google Colab. We were able to actually develop a neural net that was able to combine perspective and depth math into a 3D simulation. Now, of course, certain other software, they have that embedded, but we were doing it actually creating our own maps and our own approximation systems and our own depth approximation by coding. The problem of Midjourney that you probably know is the API. The API is actually retrieving images real time without the authors of the images consent, breaking all international copyright laws. And so it's not only the bias of the semantics, the bias of the grammar, but actually the problem that this content belongs to certain people. And the interesting thing to me that nobody discusses and that we discuss in the book is the digital feudalism, that the fact that it's a top-down money-making machine that is profiting from the production of all over the world, activating a socialism when in reality the individual has to actually pay for it in a most brutal capitalism, right? So socialism for the top and capitalism for the bottom. That's what we are living in now. Why? Because if you want to compete with this, we are trying to compete with them. If you want to compete with them, it's very hard unless you unify computers in large networks that we're trying to do, develop our own repositories and try to elevate the level. This is a 2D to 3D approximation point cloud. And we're actually training our own system to recognize 2D to 3D, 2D pixel to pixel, but also 3D point cloud approximation into 3D approximation. The resolution of them are not really great. These are, some of them are 1,000 iterations, which takes a lot of time and a lot of money to do if you own little resources. We do it in the cloud and still requires a lot of training. But we arrived to 5,000 epochs. And of course, the pre-trained, the GPT, ChatGPT, which is pre-trained, we're talking about trillions, right, of parameters and billions of iterations. So there's no way in our entire life with all the resources that we can manage that you're going to be able to compete with them. But this is a demonstration of what we can do by thinking about how to take shortcuts and actually how to train our own systems. We get somewhere. We're actually predicting 3D. We were one of the first ones, I think, to actually do this back in 2022 and early 2023, predicting a point cloud directly point by point, obviously based on the definition of the model, but actually creating a 3D a prediction model out of the 2D model, not based on depth, but actually a total AI reconstruction. We work a lot with ChatGPT and Midjourney, DALL-E, and all the systems available as everybody's doing. And I did my experimentation with mathematics, with topology, very interesting, but I was not happy. I was not happy because I believe that we were not activating the real meaning of artificial intelligence until we arrived to this. This to me was a breaking point in my research in 2022 and the decision to actually publish the book, which is that I believe that we were able to activate emergent programming. Emergent programming is a very specific type of artificial intelligence. It doesn't really happen all the time. You have to train a lot the model to actually be able to do it. But if you are familiar with definitions of intelligence, if you are familiar with definitions of information processing, and if you are familiar with von Neumann definition of artificial life, he called it artificial life, I believe that we were able to activate artificial intelligence in 2022, which is through natural language processing, we were able to activate higher level programming language, and we were able to activate a simulation of a simulation. Why do I say this? Because in this one, these are simulations, right? They are not simulations of a simulation. But in this one, there is a simulation of a simulation. And why do I say this? It's not only that the image is constructed by interpolation and statistic, but I believe that there is an emergent program that is actually recognizing in 3D, which is what the Midjourney is prepared to do. But the difference is that there is a running program over the simulation. So the mid-journey simulation is having a task, which is perspective, rendering, right? All these type of simulations, but we're actually activating the beginning of a sentinel, by the way, which is to actually model a computational fluid dynamic simulation in relationship to a previously simulated model. So this I call simulation of a simulation. I think it complies with the definitions of von Neumann, and I think that it's not the same, that I think that there are different levels in ChatGPT and different levels in Midjourney, and that the developers don't even know what the system is able to do. Why? Because we are dealing with parallel processing. And these are early experiments, July 2022. These are more recent experiments. You know, I said that pixel-to-pixel deals with thermodynamics, and we're trying, in all my work, if you know my work, I try to match the signal and the sign to index the system in which the sign is being produced. And what I'm trying to do here is a simulation of the simulation, but also to try to activate this digital signifier to try to deconstruct the digital signifier. So in other words, the thermodynamics that is going on to construct the pixel simulation, use it as part of the model making, right? As part of the simulation. And we are experimenting, creating architecture. And the architecture here is linguistic and it's a problem. I actually don't like architecture to look like buildings. I prefer this, but this is more what people expect for architecture. It's funny, but I'm more interested in the thermodynamic system of the architecture of the architecture. So the politics of these data, I think that they are everywhere. It starts with a survey, and I'm going to show some survey projects. It starts with data gathering. It's in the all databases are biased because they are based on linguistic visual features that are programmed, therefore they're anticipatory. And the idea is how to move away from them. How can we build up ways to actually deconstruct semantics, deconstruct the grammar towards a higher level grammar, how to think about neural networks in a different way. So for instance, one of the things that I criticize in neural networks is extreme decimation, signal decimation. And I discuss in the book the problem of stacking layers in making the neural networks very big to try to resolve a problem that we're not sure of because of a hidden layer. The hidden layer is purposely there to hold the key of the unstructured data. But the problem is that it expends excessive amount of energy. So millions of people are using Midjourney, ChatGPT, wasting a lot of energy because of the signal decimation. And I argue that what I'm trying to do with biological neural networks or analog computing is actually to come back to the fidelity of the signal in relationship to the computational system. Another issue that we are going to discuss in a future lecture is thermodynamics as part of the problem of artificial intelligence, and how to go beyond the linguistic paradigm in terms of non-semantic by unsupervised learning. So here quickly, I'm going to finish showing some data survey, big data that we have been actually working through many years, some of the generative processes that I work with, comparing back and forth here. This is on the left side, linguistic tagging, meaning you can do a semantic segmentation of the point cloud. We actually, I think we were one of the first ones to actually work. I was having this conversation with Andrew Saunders and Graziano Valenti, who's here. Thank you for coming from Sapienza University. When we were doing the 3D scans in Italy, the problem to me was the fact that the point was totally unstructured data because it's RG value XYZ. So how to assign value to a group of points that had no meaning? So we developed some algorithms to actually recognize semantic segmentation, but then that became the problem. And then later on in the last 2 years, we have been developing non-linguistic visual feature-based segmentation that is based on neighboring relationships at the level of the point cloud. So these are the two linguistic and non-linguistic paradigms that we're working on. These are big data 3D scanning, 250 million points, semantic segmentation, classification, approximation, right? All the data sets and the value. I'm going to discuss in a future lecture. I'm going to get more in depth about the work of Romini and Rinaldi, because I try to also deconstruct the history of architecture relative to what we know about architecture by 3D scanning the buildings and sectioning them and reclassifying them. But today I just wanted to show you some work, since we're in the context of the Venice Biennale, and it's some of the research of the students, some of the work that we did at NYIT with our students in our research studios and seminars. So for instance, 3D scanning with photogrammetry, the Met and the Guggenheim Museum, and developing a big data repository articulating the art repository collection in relationship to the building, augmenting the building and crossing back and forth between the Guggenheim and the Met. Very interesting project, which allows us to not only 3D scan, but actually take point by point and assign an agent to each point and create its own emergent logic, meaning that the building could be augmented into a virtual reality navigation as a type of model for a museum of the 21st century, and go back and forth between the API of the actual painting collection and the retrieving 3D scanning the Met Museum, and combining what Salma Katas, the student, called the Museum of Babel, which was based on our study of the Library of Babel, rewiring all the 3D scanning through semantic segmentation and transferring it into the Guggenheim spirals, but then changing the Guggenheim spirals also, right? And this is some of the work that is exhibited here now. I show some animations. We are dealing with a video card. I don't think they're going to run, but maybe I keep them. You can see them online. Some of these animations are online, but basically here we deconstructed the pixel of the artwork in order to actually reclassify it and distribute the pixel of the artwork in relationship to the experience of the space. Well, it's not running. There you go. So then the pixels of the artwork became the space, literally. This is the Met Museum, 3D scanning the Met Museum, 3D scanning the Guggenheim, and then combining them into the point clouds themselves, making them agent, each of them becoming an agent, and creating a model, but also the model deconstructing into a data set and deconstructing the relation between the data set and the model. So articulating really data science and computer science, and combining into a different type of architectural space. These are navigations of the reconstructed data set. And then these are more abstract, right? Reconstructions, in which each agent, each particle, right? I said that we deal with diffusion models with pixels, but also we do diffusion models with particles. So the particle system that is simulating a thermodynamics, it becomes itself an agent. And I'm going to show another project that also deals with that. Meaning that instead of having an overall structure, each particle becomes its own rhizome. But the less, I think that everybody was after the rhizome in the 1990s, and I believe that we were able to activate the less rhizome at the level of an architectural model through the 3D scanning and making the 3D scanning an agent, a multidimensional agent. And this is the last project, 3D scanning of the High Line, 200,000 pictograms and millions of points done by the students, right? So, by the way, we don't deal with data repository. We develop our own data. We acquire our own data, and we train our data set, and we develop our own algorithms eventually, some of them. This is non-semantic, non-linguistic segmentation based on neighborhood approximation. And these are when each point becomes its own agent, creating its own figuration. In this case, there was a social project of deconstructing the linearity of the High Line in relationship to local art galleries. and also working with pixel-to-pixel diffusion models and articulating back and forth points and pixels to create a more dynamic way of understanding what is the logic of the point cloud in relationship to the data set and how the point cloud can become its agent. And when it becomes its own agent, you recognize its own task because it's unstructured data and starts doing, obviously work with different known algorithms, but made our object each one algorithm. And therefore the approximation of that that's now the foremost, right? And there are other projects dealing with point clouds in a different way and making that in out the city, constructing the city, and with this all right, so this is all what I wanted to share. I apologize, it went a little bit beyond the time expectation, but hopefully the lecture was clear. Thank you so much. All right, so now I guess we go to the discussion. So Graciano, I don't know if you want to join us. No? But Alexis is here, the respondent. Thank you, Alexis, for coming here. Thank you for listening and for. I think we're okay. We don't need because we are here. Yeah. Okay.
Well, Pablo, thank you for the presentation. As usual, it's very passionate and precise, and like precision in theoretical fields. And first, I want to thank Pablo. Eiroa and the New York Institute of Technology for inviting me to participate to this event around the presentation of these new Pablo's books. Well, I also apologize for I think I lost my voice in the plane yesterday. I'm so and the theoretical and experimental approach proposed in the book the definition of a new architectural signifier, a digital signifier. Now we know thanks to your presentation. Surrounding Derrida's economy of language, Pablo's intent to reform the tool of architecture to develop an architecture of architectures. In addition to the historical panorama, which is in the book, the work contributes to modeling the logical laws, which from Aristotle to Leibniz characteristica universalis determines the ontological conditions of the relationship between what appears on what one can know, on what one can express. From then on, we understand the continual critical approachments that we find in the book between data and signifiers and between information and representation. So, I will be very brief after your precise presentation, but I have a few remarks. So, the object of this work to me could be taken as a critical studying of what may be a spatial environment today produced by new technological tools and new semiotic entities named a digital signifier. These semiotic entities let open a series of displacements in systems of representation, especially conventional, until the advent of a kind of, as the author says, a digital humanities. Of course, those structural statements does not come from nowhere, and it is particularly interesting to observe the way in the text Pablo Eiroa merged different philosophical traditions. One from the logical positivism that relates any fact with linguistic structure, including, as we all notice, an anti-metaphysic aspect, probably inherited from the Vienna Circle on his manifesto published in 1921. I will remind later the name of this manifesto.
Yeah, but I don't
It
remember.
is the scientific condition of the world.
Yes.
Another tradition come from the deconstruction movements, which I say in architectural terms, that is which take its origin to be in the semiotic debates opened by Panofsky's iconology theory or Peter Eisenman's lexical decomposition process. Here, to be brief, the sign is related to meaning from a syntactic relationship between the different elements of the formal structure as algorithm. For example, it could be true also for arithmetic structure. Even if Edmund Husserl, the German philosopher of the 19th century, proposed in one of his first books, named, I don't know if you know it, named precisely semiotic, in 1891, that arithmetic finally relates to a simple sign game that is out of conceptual or cultural representation. So now, in order to open the debate about your work, behind operativity and technological performativity, as long as you reduce structural expression as a communication system, isn't there is a risk here to see appear a cognitivist reduction of the spatial experience to the detriment of its affective and sensitive nature? Does this suppose that architecture can be generated by the codification process and reduced to a communicational system? Because to me, from a material artifact, architectural representation is correlated to perceptive abilities of the user and not only by the organizational logic of the shape or structure. Another unfinite word is the grammar exclusively empirical and correspond also to other dimension of our sensitive and aesthetical consciousness. How your digital signifier will respond to that? From which point your digital signifier became an architectural sign? Thank you.
All right. Thank you, Alexis. By the way, I have to thank you also for Alexis Meyer's critique of the book is actually included in the back cover of the book. It's actually very well written, so I really appreciate your precision and your expertise because you understand the problem very well. So I really appreciate your synthesis of the book. I knew that was coming, and usually that question comes. What about experience? All my presentations, and it's because I literally ran out of time I don't want to make my presentation 20 hours, right? But my work, I am from Latin America, right? So my work is a reaction to my context. In Latin America, experience was first and material was first, right? So we start an architecture project out of the materiality and the experience. So I always question my professors. We talk about for instance, one famous thing in first year, the teaching was the metaphysics, which is very interesting, and I totally agree now, right? Now that I look at it in years ahead, the metaphysics of the gravity of architecture. That's to me the most powerful embedment of the experience. The fact that a building has to really deploy a lot of resources structurally, right? That's to me the point of contact between deep structure and experience. The structure breaking the metaphysics of architecture, which is what Le Corbusier did with the free plan, right? Elevating the building, or some architects do with a gigantic cantilever, right? That you feel the presence of the absence of the structure and you get scared. That's one. Another article that I wrote about that is based on Palladio. Palladio, to me, is an architect that, not by chance, is an architect that defined architecture. And why? In Palazzo Chiericati, I discussed the relationship between experience and structure. And why the Palazzo Chiericati? Because Palazzo Chiericati is a very compressed space. It's a series of layers, right? It's very compressed. So when you enter the building, you feel the pressure. So how do I transfer that into the digital signifier? Is your question. And what I did in the last chapter, and it's with virtual reality, what I did in the last chapter, I tried to articulate in the last two chapters. On the one hand, the problem of virtual reality and an expanded reality based on the Pritzker Prize winners last year, which I totally agree with them in terms of that we need to stop architecture developmentalism. We don't need to build more, right? So one way of not building more, that's what I'm doing with the survey, is actually expand the building virtually. But the interesting problem of the experience comes in if the eye of the beholder, of each person experiencing the virtual reality, is able to change the structure of the simulation. That's my, and for instance, there is a system that stereo diffusion, right? There is an AI system that allows you to change the camera, and each time the camera changes, something grows by prediction, right? So we play in the last chapter of the book with the fact that the camera, and we're actually developing a video game and based on mood. In the last Biennale in 2022, we did an installation, a pseudo installation, because we didn't finish because of COVID, but we proposed a space that was recognizing mood in the subject experiencing the space, and that mood, AI sensing, would change the virtual simulation, right? Real time. So that's one. And another one, but how do you arrive to the structure? That's what I'm interested in. How do you arrive to change the morphogenesis of the structure? And what I propose in the last chapter, obviously you need quantum computing. You cannot do it with other type of computation, which is that multiple people looking at the same space would be able to simulate themselves in parallel simulations, changing the actual space. And then you have an adversarial construction through the point of view of each of the. And I developed the theory of it. We didn't resolve it technically, but the idea is that an AI machine vision could actually develop a way of seeing that actually changes the structure of the space. So that's my answer to your. But I agree that I first with deep. I start with deep structure, but the objective is to arrive to experience, and you can do it the other way around. You can start with experience and arrive to the structure. But in terms of computation, I think that we are actually loaded with images. There is too much affect, and there is little knowledge because of the fact that I think that we live in a totalitarian regime of big data, right? That very few people own everything, right? It's 6 companies that own all the data of the world, right? And that is a problem. So the question is how the subject can become an agent in terms of that, right?
Okay.
So I don't know if I answer your question, but that's what I'm trying to do in the last 2 chapters.
There is good precision and good example. Thank you. My observation is more related to the relation between expression and representation. I feel through the work, what you pursue, what you want to have finally is something that a kind of sign that can be out of representation. Because in representation, you find, as you say many times in the book, there is some kind of determination, cultural aspects, and also a kind of regression sometimes. But all the things that we all know from Eisenman studies on the side of this motivation, and I'm agreeing with this, of course. But my idea is how how your sign could work as a sign, maybe a digital sign, if you want to name it like this, without this aspect of representation, because it is because our consciousness make a sign from something.
I think
So how could you escape predetermination and representation?
I think that there are two things. There are two questions. One is representation.
When you play with some sign that people maybe can't recognize.
Exactly.
That's the thing.
Okay, so I include a discussion in the book, which I call the sign, which is to deconstruct the sign, right? First, you need to acknowledge the sign, otherwise you cannot communicate, right? There's no message. So Palladio, for instance, was very aware of the construction of the context of the message. How do you create a sign that you can deconstruct, right? So that's one aspect. But the problem of representation that you're saying, I don't agree. In the book, I do a bet. My bet is that we are in a representation restricted reality. We cannot access reality. I think that we cannot access reality other than a media or a medium. And that separation creates a struggle. And I think that most of the time, like for instance, ChatGPT doesn't recognize the mediation. They tend to normalize reality as if the system of representation is not an issue. And that's what creates the bias. The lack of deconstruction of the recognition that there is a separation between us and reality. And that separation starts with language, the speech, and the writing, and then it continues with perspective, drawing, and so on.
I agree with the fact that, of course, we don't live in, we take the reality to build our representation, but it's not the reality. By the way,
Yeah,
sign only exists in our consciousness.
exactly. The aliens don't have.
Of course, for that I agree with. So my question is how you make your sign out of representation in our ability to communicate.
I think, well, I included 4 steps in the book. One is the analysis. I think that, for instance, one of the problems of image making in ChatGPT and Midjourney or all the AI systems is the lack of process. Like architects are not able to access the process. If you do not access the process, you cannot do analysis. So my first step is gather your own data. The data that you gather already includes a sign because you're going to use a measuring system to gather the data. So the problem starts already in the survey. How do you measure reality?
A sign or data?
They are not separated because there's no data.
That's the big difference.
There's no data without representation. I argue. Some people believe that there is data without representation. I argue that there's no data without a system of representation. You cannot have, in other words, a measuring system measures reality and stretches reality, distorts reality.
It's a debate. I don't know. I say there is no sign without representation, but data, I'm not sure.
Well, that's what I discuss in the book. That's why I start with human proportions, because everything is anthropocentric. And how do we go beyond anthropocentric systems? And I think that by the way, the crisis of the environment, I think, is related to our anthropocentric systems of measurement. That we understand nature as the other, because we are understanding nature linguistically as a signifier, and we are not part of nature. That's why actually pre-Columbian or pre-Columbian civilizations don't have that problem. They are not separated from nature. I think that one of the Eurocentric problems is that we are separated from nature, and linguistically, right, is the other.
Nature, even from the Maya, is also a representation.
Yeah, of course. Nature doesn't exist.
Of course, they
Right?
exist in their consciousness,
Exactly.
structure of meaning.
Nature is a construction.
That is gained by long with
Exactly.
Just to pick up your last example that you just showed at the end of the presentation, which I found very interesting, this remark, just to know better about it, maybe to solve some kind of theoretical problem about it. is what the Husserlian theory, maybe not at the end, but at the last part of his work, speak about intersubjectivity. And he speaks about intersubjectivity through the problem of experience and judgment. And he prepared that only the semiotic mechanics can solve the problem of intersubjectivity. And I found what your intuition to mix and to let things as a kind of auto-organization, different or parallel point of view, could be maybe
that's the problem. That's the problem. And actually,
because to finish, of course, what is difficult is the represent that you have the design when you design it or you draw it or you program it. How do you know that the people that in their consciousness have the same representation that we want to make, not the same signification? It's the basic of the architectural model.
I think Palladio was a genius on that, because Palladio did a machine exercise to introduce you to the problem. Like he gave you that's what Terrani did in the Casa del Fashion, right? He gave you a reference system, which then he alters, right?
I've seen all the genius in architecture
Do that.
They do that.
Yeah. They do like a pedagogy, right? A deconstruction of what architecture means and a teaching of what architecture is. Exactly. But Husserl, the problem of Husserl, I think, by the way, video game is a video gamer's dream, is to do that. The fact that the video game can be developed by the user, right? The user experience constructs the screen. I remember Graciano, when Graciano was working very early on VRML, when you did the model for 2004 of the Venice installation, you were working in VRML already, and I was thinking, you know, like, actually Michele he's also here. He built you remember, right? He actually built the installation. So the VRML problem, which was the subject moving in the space, was already the activator to me as a problem. How is the user would be able to change the morphogenesis? It's very complex because you have the morphogenetic system. You have by the way, I talk about site-based computation, right? Similar to the problem of the subject is the problem of the context. Like, can you do a computation that is based on the context? And in the last 5 chapters of the book, we discussed what is site-based computation, which is the problem of cell automation. And cell automation, in terms of generative process, could eventually lead to a problem of the subject. The subject is not included in cell automation, but that's what we're trying to do.
But the subject is included in the representation.
Yes,
whatever you do.
But the problem is that it's perspective. While we still deal with perspective, right? And I think that we have a struggle because AI vision is all based on perspective. How come? And we're 500 years away from perspective, and still Brunelleschi is winning. It's like the hero here is Brunelleschi, and I'm trying to deconstruct Brunelleschi, right? I'm not trying to confirm. I include what Velázquez did, right? That Velázquez tried to break the subjectivity of the perspectival point of view by inserting himself into the painting, right? Or what Palladio does against perspective, right? That flattens the space. So there is a lot of discussion about what are the resources that architects have in order to resist the signifier, right? And that's what I'm trying to develop new signs and new signifiers.
Yeah, as long as we have in mind that when we deconstruct an architecture outside, traditionally you deconstruct the semantic charge of the sign,
exactly,
not the sign in itself.
That's the problem.
Yeah, of course.
That's the problem, because
if it was only easy to deconstruct the sign, exactly, to change the meaning.
But that's I'm surprised how everybody forgot this, because
that's the main principle.
Yeah, but if you read the articles on AI published lately, they're all supportive of semantics. And I say, what are you talking about? I mean, we forgot the last 40 years of architecture. And I think that obviously they are reacting against formalism, but you can only talk about grammar if you're a formalist. You cannot avoid the formalism of grammar. And I think that that's a problem that certain architects that they try to do well, you know, that that they say my political project goes against form. Yeah, good luck, because how can you make sure, that's what Derrida says, how can you make sure that you're not applying what you're trying to resolve, right? That's my problem with politics in architecture done in the wrong way. I think I'm doing politics through the signifier. But if you do it without the media on the medium, you fell into the trap that you're trying to do good, but you're projecting the same structure that you're trying to resist. Derrida was aware of that. When he critiqued the socialist structuralists, right? He was pointing that out, right? People that were going to decipher the myth, but then they were falling into the same Eurocentric structure that they were trying to depict, right?
Yes, but have in mind that what Derrida say that the end of his architectural study is that if you deconstruct architecture, there is no more architecture.
Yeah, but that's
so we are in between.
Exactly.
That's why the program
Absolutely
is interesting. That one.
But you can leave too far. Yeah, exactly. All right. I don't know if there is any questions from the audience or Marcella, if you have any comments. Or if Graciano. Yes.
Hi. So yes, thank you. I have some comments, but I don't know if I want to go to the in-person first. Mostly, yeah.
They are shy. They're a little shy.
So I have actually two questions, maybe as a bridge. And so thank you for the presentation. It was very rich and very dense, but I think it was great to see the body of work in terms of how, you know, in a way, how, you know, the research started and how this evolved up to now. So as an overall framework, so I want to, so my question, two reflections here. So I think very interesting, you know, when we you know, that we cannot really think outside the language, and really this dichotomy between grammar and meaning is really the base, let's say, problem that in a way start to, you know, it's really the base problem, I think, to begin to address. So where basically, in a way, if you look at meaning and we look at semantics, we understand that semantics are not relevant. So my first question is that how do we give back semantics, but also what type of semantics we can give back through this new level of authorship? And so this, I think, goes back to the other question, because in the end, it's how do we elevate, you know, one of the part of the discussion is how do we elevate the level of authorship, and how we can begin to address this notion of expanded authorship as well. And so this is when you started talking about the emergent programming as a type of AI that can be introduced to basically bypass this this problem somehow. And so I think at the end, when you show the images that look at how we can begin to bypass the bias of the signifiers, I mean, this to me, it's really the center part, I think, of the presentation as an endpoint. And so this, I think, and you started talking about that emergent programming as a new type of AI. Also, the key in the end is how you train the model. And so my question here is, how do you train the model in order to bypass the biases as well? So in the end, it's two questions, right? How do we begin to engage through the practice, this expanded level of authorship, also in the training the models? And the second one is a more question related to this dichotomy between meaning semantics and grammar, and what type of semantics we can think of as well.
Well, thank you, Marcella. The problem of semantics is that is interpretative and is subjective, right? We were talking about subjectivity before,
right.
Husserl, but this is a problem. Semantics is a problem because, and this is my fight with computation in general, because Claude Shannon, and this is something that I'm very clear in the book, devised the fact that the message is scrambled into data, communicated because of an economic problem,
and then reconstruct it again, right? That's information theory. My information theory, that can only be done with semantics, by the way. The signal transmission means that the message is at the level of semantics, because the meaning is deconstructed into meaningless bits and then reconstructed again into meaningful bits that become information. So data becomes information. I think that I was one of the first ones to declare that problem. That to me is the bias of computation. That is computational software developers not studying humanities, basically. Like, and I think that there are new, for instance, in the 1970s, there was a field of knowledge that was computational art, that where artists were developing their own software because they were realizing all that. That became media theory, and right. And I going to your question of the author, I think that the author, we had to recover that project of the 70s in terms of developing our own coding, because if we don't do that, we fall into a colonialism. I argue, I don't think anybody said this before, but I argue in the book that computation is a neo-colonialist system, and that's why the big data, the big companies are doing better, right? Technology and capitalism are part of the same equation, and the bias are a consequence of that capitalism. The more you spread the system, the more universal, the better, but that becomes an empire, right? An empire of Google, an empire of Facebook. And I think that the neo-colonial problem has to be deconstructed at the level of authorship, because today, and one of the things that I say in the book that is, I think people are going to be a little bit nervous about what I'm saying. But I say in the book that if you don't own the means of production, you are not the author, literally, right? In other words, if you don't develop your own algorithms, if you don't develop your own data, to me, you're not the author. And there are different legal, I discuss authorship and authority in the book in the last chapter, legally, right? Because I met with different lawyers, and they orient me in terms of what's going on with the law at the level of digital science. And it is a big problem. And I think everybody's looking the other way, pretending that they don't know, while the big companies are having everything, right? They're taking everything from us. So I think that relative to your question, the semantics is something that we need, is biased. Semantics to me is biased. Mm-hmm. But the problem is that the semantic, if you look at semantics, there was an article by Stanislaus Chilau, which was, I was somebody that I was following, a student of, what's his name? He works with architecture and mathematics. I don't remember his name now, from Harvard. And his thesis was one of the working thesis on AI, and I knew that that was a problem. But now he wrote an article in, I think, ArchDaily or Archinect about semantics, and I said, oh, this guy is lost. He's totally lost. So you know what I mean? Like, I think that the confirmation of semantics is very dangerous, because it's the confirmation that we have no power against the big data companies. It's like saying, okay, if we are the ones that provide the meaning, that's why I'm not interested in creating images with Midjourney, as everybody's doing, because the meaning production, to me, that's irrelevant. It's not important. We can do millions of images, but if we don't access the process, we are not part. We are actually, what I claim in the book is that we are the product. We become the product because we are training the system. We're actually helping them to take us out. You know what I mean? It's like, it's terrible, because we are helping them train to push our authorship down instead of doing the other way around. So that's, I think that we should do this, and we are doing, every time we're more away from creativity and authorship.
Yeah, because in the end, it's about, I mean, the whole core here is bypassing the biases. That's it, right? Because in the end, when you put sky into Midjourney, there is already a bias that you mean, okay, I mean, sky, it's that. And so there is an associated image that will basically use that word specifically to get that output.
I mean, the bias is being dissociated by interpolation. We have to be careful, and by convolution, but without knowledge, you know, and that's when the danger comes in, because yeah, you can bypass through interpolation and feature recognition
Step,
through
yeah.
convolution, you can go beyond the bias, but not really beyond the reference bias. And that's when, to me, the problem starts. And that's why, to me, the only solution is to go beyond the structure of the system, which I've been claiming since 2010, right? How do we deconstruct the structure of the system, right? Which is difficult, but that's what. By the way, developing your own media, right, is the challenge today, and developing your own medium. That's what I'm claiming. And hopefully I'm able to work more on that level now that I finished the book in different projects, but that's what we're trying to do. But thank you, Marcella, for the comments and the feedback. I don't know, there's some comments in the chat. Vanessa is algorithms for authorship, looking forward to evolving into further questions. Thank you, Vanessa. All right, I don't know if there is any other questions or comments. The audience here is shy, it's very shy. The English, maybe, Italian. But, all right.
Okay, great.
Okay, thank you so much. Thank you, everybody. Hope that you buy the book and we continue the conversation.
Bye, everyone. Thank you.